Welcome to our last online study session. This is for MAT1033C, Intermediate Algebra, and this is the final exam review study session, version A. I'm still here for you today, so I am able to help to prepare for your final exam. Let's go to our first question. This is problem number 1, and it says solve the absolute value equation. So if you have an absolute value equation, and that's indicated by these two vertical bars, the first step would be to isolate the absolute value on one side of the equation. So I'm going to isolate this absolute value portion on the left side, and I'm going to move the 9 to the other side by subtracting 9. So I am not doing nothing with the absolute value yet. I'm just going to bring it down, but then my 9 is gone on the left side and I moved it to the right, and now 13 minus 9 is 4. So now where I isolated my absolute value, I can use the property to solve absolute value equations, which means I'm going to get two different answers because the absolute value is the distance on the number line. So you could go in the negative direction on the number line and on the positive direction, and you indicate that by writing two equations. One time with a positive 4 and then also with the opposite, which would be a negative 4. So let's solve these two equations now individually. Let's start over here. We subtract 3 from both sides. So we are left with 6x is equal to 1. Then dividing by 6 on both sides, and we get x equals 1 over 6. So we have our first answer, and now let's do it again. So subtracting 3 from both sides, we have 6x. And then negative 4 minus 3 is negative 7. Last step, to get x by itself, divide by 6. And that leaves me with x equal to negative 7 over 6. So for this absolute value equation, we basically get two answers. One of them is 1 over 6, and the other one is negative 7 over 6. If you should not see your answer, then you might want to go back and plug these back into the original equation to see if you get true statements, because sometimes it happens that there is an extraneous answer, so that would be a no solution. But in this case, you are able to find the solution. Let's go ahead and see what number 2 wants from us. Here we go. Solve the compound inequality and give the solution set in both set builder notation and graph form. So we have negative 5 less than 8x plus 3 and also 5x minus 10 less than 5. These are two inequalities, so let's solve them individually. Let's start with the left side. So basically we are solving for x, so I'm going to move the 3 first by subtracting 3 from both sides. And negative 5 minus 3 gives me negative 8. And then I have 8x left, and this became 0. Okay, my last step to get x by itself is dividing by 8 on both sides. So negative 8 divided by 8 is negative 1. And 8 divided by 8 is just 1. So my x is by itself. And I can also rewrite it because I like my x to be on the left side, but I need to make sure that the value of the sign still is the same. So basically the x is greater than negative 1. So both of these answers are correct, but I prefer having the x on the left side. So now solving the second part. So here again we're solving for x. Let's add 10 to both sides. And we have 5x is less than 15. Now dividing by 5, and x is less than 3. So in this case it came out nicely with x on the left side. I do not have to rewrite it. Now first of all they want me to graph it, and here's already my number line, so I need to make sure that my negative 1 is on there right here, and then also my 3, and then I have greater than and less than signs. So that means that I am going to use parentheses instead of brackets, and let me erase them, not that you think it's a greater than or equal to sign. So the parentheses go along with these two signs, and then the brackets go along with the greater than or equal to sign and the less than or equal to sign. So in our case, we only have these signs, so we're dealing with parentheses. So at -1, it says x is greater than -1, so the numbers are greater than -1, which means the side to the right of -1 should be shaded. And on the second part, it says x is less than 3, so the numbers that are less than 3 are to the left side, which means everything in the middle would be shaded. So actually, the shading from the -1 would continue over here, and the shading from the 3 would continue over here. But because we have AND, which means the solution is only where the two shadings happen, so what is the solution of both of these inequalities, and that is in the middle. So writing this in set builder notation, we need our curly braces and then x such that, and now you see how x is in the middle? So it started at -1 and x is basically greater than, which means this sign, and then x is also less than 3. So this would be our solution in set builder notation, and this would be our graph. Let's move on to number 3, which is similar, but in this case it actually says OR. So the same steps as before, we first have to solve both of these inequalities separately. So let's start with the left side by solving for y. So let's subtract 5 from both sides, and we have -4y is less than 17 minus 5 gives me 12, and then dividing by -4 on both sides. And whenever with an inequality we multiply or divide by a negative number, like in this case, then the sign gonna switch in the opposite direction. So in the previous problem, we never divided or multiplied by a negative number. The sign didn't switch. We only rewrote the problem at the end. But in this case, we're dividing by a negative number, so we're switching the sign. So on this side, y is by itself, and 12 divided by -4 is -3. Now solving the right side, again subtracting 5 from both sides, and we are left with -4y is greater than or equal to, and 33 minus 5 is 28. Last step, dividing by a -4. Again, we're dividing by a negative number. We have to flip the sign in the opposite direction. So this side is just y, and 28 divided by -4 gives me -7. So in this problem, we don't have to write it in set builder notation, but in this case, they want it in interval notation. And I'm going to graph it first because it's easier for me to write it in interval notation if I can read it up from the graph. So I need my -3 and my -7 is right here. And then pay attention to the sign. In this case, we have a greater than and then a less than or equal to. So for the -3, which states that y is greater, so the numbers are greater than -3, and because of the sign I need parentheses, and the numbers that are greater than are to the right. And then the second one says y is less than or equal to -7, so the numbers that are less than -7 would be shaded to the left. And in this case I'm using a bracket because it has the equal bar in the bottom. So now I have my graph, and now I can write it in interval notation by reading my graph from the left. So starting here, the shading starts at -infinity, and infinity signs, no matter if negative or positive, always get parentheses. So starting at -infinity, and then the shading stops at -7, and like I already indicated, we need a bracket, but because it says OR, we have a union, so it could be either or, both of these shadings. And then the shading starts again at -3, and in this case I have a parenthesis because of the sign, and then the shading ends at +infinity, and again +infinity gets a parenthesis. So this is my solution written in interval notation and also in graph form. Alright, let's move on to question number 4, and it says, write the equation of a line in slope-intercept form assigned through the given pair of points. And In this case, we are asked to write a line in slope-intercept form. So I'm going to write my slope-intercept form here on the side to remind you and myself. So it's y equals mx plus b. That's the slope-intercept form. This is how I want my final answer to be. And I am given 2 points. So when we are given 2 points, we basically can use another formula and find the slope first. So the slope formula is m equals y2 minus y1 and then x2 minus x1. So I hope you guys remember this formula. Let's label our points. This is our first point, so I'm going to label it x1 and y1, x2 and y2. And then I am going to plug in these numbers into my formula. So starting with y2, I have 3 minus y1, which is 7, and then over x2, which is 0, minus x1, which is negative 7. So the first negative is from the formula, and the second negative is from the actual coordinate. Okay, so I'm going to simplify top and bottom. 3 minus 7 gives me negative 4, and then 0 minus minus, this actually turns into a plus. So 0 plus 7 is just 7. I always have to check if I can simplify or reduce my fraction to lowest terms, but in this case, this is my final answer. So this would actually be my m. Now I have my m, and I need to write this in this equation. So I could use another formula, which is called the point-slope form of an equation. Y minus y1 equals mx minus x1. And I can use this form of an equation to plug in one of these points, and I'm going to pick the second point just for the reason it looks simpler for me and I don't have to deal with negative signs. But either one of these points would give you the correct answer. I'm just going to choose the second one, and then I have my slope. So I'm going to plug all this into my equation. Y minus, so my y1, in this case I'm picking this point, so my y would be 3, is equal to, I found my m, which is negative 4 over 7, and then x minus x1, and the one just, refers to the point which I picked, so my x is 0. I'm going to solve this now for y, so it's nicely in the slope-intercept form, but before I can move the 3, I'm going to distribute to eliminate my parentheses. So y minus 3 is equal to negative 4 over 7 times x, and then negative 4 over 7 times 0 is just 0, so I don't really. Last step, adding 3 to both sides, and I have y equals negative 4 over 7x plus 3. This is the equation of the line in slope-intercept form, and this equation or line would pass through these 2 given points. Question number 5. So find an equation in slope-intercept form of the line satisfying the specified conditions. So this line needs to go through the point negative 5, 7, and it needs to be perpendicular to this equation. So my first step, if I'm looking for a perpendicular line to this equation, I need to find the slope of this equation. Because perpendicular lines or parallel lines, you could have either one of these 2 versions on your final exam. What is the special thing about them is that they are slopes. For the parallel one, the slopes are the same, and for the perpendicular line, you would need the opposite reciprocal. So let's first solve this equation for y. To be able to know what is the slope, we have to solve this equation into the slope-intercept form, which was y equals mx plus b. So let's solve this for y. Negative 4x plus 9y equals negative 43. So solving for y, let's move the x term to the other side by adding 4x to both sides. This leaves us with 9y is equal to, and I'm going to write the x term first, so it's in this form. So 4x minus 43, and then dividing by 9 each term, and I got y equals, I cannot simplify this fraction, so that's fine, 4 over 9x minus negative 43 over 9. I don't really care about simplifying it or not, because this term is nothing that we really need. We're basically just looking at the slope, which is this number. So our slope would be 4 over 9 but now the instructions say perpendicular, so the perpendicular slope of this line would be the opposite, which means if this one is positive, then the opposite would be negative, and the reciprocal, which means these two numbers are just flipped upside down. So the slope of the line that I'm actually trying to put together would be -9/4. And now, just like in our previous problem, we need the other formula, which is the point slope formula. So y minus y1 is equal to mx minus x1. Okay, so plugging in my information, I got my point x1 and y1, and I got my slope. So y minus my y1 would be 7, and then my m of the perpendicular line would be -9/4, and then x minus, and my x1 is -5. So now I have to simplify all that and put this into just y. Let me start over here by combining these two signs. Negative times negative gives me a positive, and then I am going to distribute my slope to eliminate the parentheses. So y minus 7 equals -9/4 times x. And then -9/4 times 5, can make that a fraction as well, and then just straight multiply, so -45/4. Last step, adding 7 to both sides. Now my y is isolated, but I'm going to have to do a little bit side work, because if you remember, when you're adding or subtracting fractions, you need the same common denominator, and in this case I have a denominator of 1. So my least common would be 4, which means this side I have to multiply top and bottom by 4. That will give me 28/4. And now adding the 28/4 to -45 gives me -17. So equals, first of all, my slope, -9/4x, and then -17/4. So that is the equation of a line that goes through the point -5,7 and is perpendicular to this given equation. Give us just a second, we are switching.
Alright, so the cost of having a car towed is given by the linear function c of x equals 2x plus 55, where c of x is in dollars and x is the number of miles the car is towed. Little typo, but no biggie. Find the cost of having a car towed 15 miles. So what we want to do is that we want to make x equal 15, because x represents the number of miles towed, and so we are concerned about the car being towed 15 miles. So we want to find c of 15. So what that means is that we're going to plug in 15 everywhere we see x. So that's just here. 2 times x would be 2 times 15 plus 55. So 2 times 15 is 30 plus 55 equals 85. So the cost of having a car towed 15 miles will be $85. So just make sure that you know which value equals your x and plug it in appropriately. Okay, moving on. Number 7, find the domain of the rational function. So we have f of x equals 3x over -8 minus x. So we're finding the domain. There are two main scenarios we want to pay attention to. We want to pay attention to whether we would ever have a variable in the denominator, and then we want to check whenever we have a square root. So for this problem, we do have a variable in the denominator, -8 minus x. So remember that a number, anything divided by 0, is undefined. So we don't want the denominator to be equal to 0, because that will make our function undefined. So let's find out what would cause the denominator to equal 0 by setting it equal to 0, and then we're going to solve for x, and whatever value that is, we want to exclude that from the domain. So for solving for x, we'll start by adding 8 to both sides. So I have -x equals 8, and I'm solving for positive x, so I'm going to divide both sides by -1. So x equals -8. So what that means is our domain is going to be all real numbers except for when x equals -8. So we're going to write that in set notation. So we have all values for x such that x is a real number except for when x does not equal -8. So it's written a little differently in your review, but basically what we're saying is that the domain is all real numbers excluding -8. That's going to be your domain. All right, so that's one scenario, is checking for denominators. If you have a variable in the denominator, we want to figure out what would make that denominator equal 0 and exclude that from our domain. The other scenario is if you have a square root. So we do have a square root here. So we're only talking about the real number system for our domain. So we do know now about, imaginary numbers and complex numbers, but we don't want to include that when we're finding the domain. So we want to only focus on when we would have real numbers. So we don't want a negative under the square root. That would give us complex numbers. So we're going to take what's underneath that square root and we're going to set it greater than or equal to 0. And whatever that ends up being will be our domain. So if we subtract 12 on both sides, we'll have x is greater than or equal to -12. So that's going to be our domain. So if we're writing it in set notation, we would write it like this. So all values for x such that x is greater than or equal to -12. So just remember those two scenarios. You don't want a 0 in the denominator. You want to exclude wherever that happens. And then you don't want a negative under a square root. So set what's under the square root greater than or equal to 0. And whatever your result is, that would be your domain. Okay. So number 9, solve the system of linear equations using the substitution method. So this is when you want to solve one of your equations for a variable and then take that expression and plug it into or substitute it into the other equation. So in this case, we already have one of our equations set equal to a variable. So we're going to take x equals -43 minus 9y. We're going to take that -43 minus 9y and we're going to plug it in for x in the other equation. So I'm going to just write that out. I'm going to have -6 times -43 minus 9y plus 8y equals 10. All right, so I'm just substituting that expression that's set equal to x into the other equation. So I have -6 times -3 will give you a positive 258. Then -6 times -9y will be positive 54y. Then I'm going to bring down my plus 8y equals 10. So now let me combine like terms on the left-hand side. 54y plus 8y will give me 62y. Then I have 258 plus 62y equals 10. So now I'm solving for y, so I'm going to subtract both sides by 258. So I'm going to have 62y equals -248. And then to solve for y, I'm going to divide both sides by 62. So y equals -4. So that's half of my solution. So now I'm going to take that y equals -4 and plug it into one of my equations. I'm going to use the first equation because it's already set up to tell me what x equals. So we had x equals -43 minus 9y. So I'm going to substitute -4 in for y. So I have x equals -43 minus 9 times -4. So that's going to be x equals -43. 9 times -4 is positive 36. And then -43 plus 36. Different signs, so we're going to subtract, take the sign of the larger number, so that's going to be x equals -7. So that's the other half of my solution. So to write my answer as an ordered pair, remember it's x comma y, so my solution will be -7 comma -4. This would be my final answer. Alright, so the next question is asking about the elimination method. So solve the system of linear equations using the elimination method. So in this case, you decide which variable you want to eliminate first. Sometimes it's easier to eliminate one variable over the other, but in this case, it's pretty equal difficulty or I guess method to use. So we want to create opposite coefficients within the same variable. So right now we already have opposite signs in our x. We have a negative and a positive. In our y's we have a positive and a negative, but they're different numbers. So we want it to become like opposite, like -7 positive 7 or -28 positive 28. Then if we add them up, then they'll cancel out. We'll eliminate something. So why don't we eliminate the x terms? So I already have the opposite signs. So if I multiply the first equation by 4, that will give me -28 for my coefficient for the x. And if I multiply the second equation by 7, that will give me +28 for my x. And then if I add the equations up, the x's will be eliminated. So I'm going to write my new equations to the right. So 4 times -7x is -28x. 4 times 8y is +32y. And then 4 times 72 is going to give me 288. So now we're going to do the second equation. 7 times 4x is +28x. 7 times -4y is -28y. And then 7 times -36 is going to be -252. Okay, so now you can see I have opposite signs, opposite coefficient in my x terms. So I can now add these equations and then I will eliminate the x terms. So -28x plus 28x cancels out. And then 32 minus 28 is going to give me 4y. And then 288 plus -252 is 288 minus 252, which is going to give me 36. And so to solve for y, I'm going to divide by 4. So y equals 36 divided by 4, which is 9. So that's half of my solution. I need to get the x value for my solution. So I'm going to choose one of my original equations, plug in my y value to get the x value. So I'm going to use the second equation. It doesn't matter which equation I use. I'm just choosing the second one. So let me rewrite it. 4x minus 4y equals -36. So I'm going to plug in 9 in for y. So that's 4x minus 4 times 9 equals -36. So that's 4x, -4 times 9 is -36 equals -36. So then if I'm going to add 36 to get 4x by itself, that cancels this out here. I'm going to bring down my 4x equals -36 plus 36 is 0. And then to solve for x, I'm going to divide by 4, and 0 divided by 4 equals 0. So now I have my x coordinate for my solution and my y coordinate for the solution. So my solution will be 0, 9. All right.
Okay, let's go to problem number 11. This is a word problem and it's solve the application of systems of linear equations. So now we're going to apply what Professor Forsythe had showed you in 2 different problems previously. So it says a vendor sells hot dogs and bags of potato chips. A customer buys 4 hot dogs and 4 bags of potato chips for $10, and then another customer buys 2 hot dogs and 3 bags of potato chips for $5.75. And we need to find the cost of each of these 2 items. So let me just organize the information that I have been given in my word problem. I have 4 bags of potato chips and 4 hot dogs. So I'm going to have my hot dogs over here, and then my potato chips. So in the first scenario, I was given 4 hot dogs and 4 potato chips, and the amount of money that that customer paid was $10. And then in the second scenario, I had 2 hot dogs and 3 bags of potato chips, and that was $5.75. So because we have a system of linear equations, we need to make 2 equations out of these 2 problems. So let me call the hot dogs with an H and the potato chips, let's say C. And then when I would add the number of hot dogs times how much ever those hot dogs cost, plus the number of potato chips times whatever those potato chips cost per bag, that will give me the total amount that the customer paid. So right here, basically my two equations, and now I can use either the substitution or the elimination method to solve the system of linear equations. Because these are nicely lined up with the variables, I'm choosing the elimination method. And for the elimination method, like it says, one of the variables needs to be eliminated or cancel out. In my case, none of the variables are the same or opposite coefficients. So I'm going to choose the second equation, and I am going to multiply it by a -2. So I would have opposite coefficients right here for the h. So let's just do this and distribute through. The -2 times 2h gives me -4h, and then also -2 times a +3c gives me -6c, and then -2 times 575 gives me -11.5. So now, as you can tell, these two coefficients are opposite, and if I would add down, they will cancel out. So I'm just going to write my first equation here underneath equals 10, and then I could just add down, and that would eliminate my h, and I'm left with -2c is equal to -1.5. Solving for c, so let's divide by -2 on both sides, and I get c equals a positive, and 1.5 divided by 2 equals 0.75, so 75 cents, which means C, representing the potato chips, one bag costs 75 cents. Now we have to do it again, and we can pick either one of the original equations. I'm going to choose the first equation just because there are no decimals in there, and it just looks easier for me. But you can use either one of the equations, you should get the same correct answer. So using the first equation and plugging in 0.75 for C, and that is equal to 10. So now solving for H, I am getting 4H, and 4 times 0.75, it's just 3, equal to 10. So subtracting 3 from both sides, we get 4H equals 7, and then dividing by 4, and H equals, and we don't want to leave this as a fraction because we are talking about money, and money makes more sense in decimals, so let's convert this into a decimal, and that gives us 1.75. So that means that the potato chips was 75 cents, and the hot dogs, each hot dog cost $1.75. Number 12, which says divide the polynomials using long division. So when we're using long division, first of all, we want to set up our problem, and we are taking the second part and starting with it. So x plus 8 division bar, and then the first one, so x squared plus 14x plus 43. And we want to make sure that all terms are present and in descending order. So here it basically starts with the x and then it goes to the constant, so we're good here. And then over here it starts with degree of 2, and then it goes down, even though you don't see it, but it has a degree of 1, so it goes down 1. And then basically here a degree of 0, which makes this x disappear. So yes, they are in descending order, and none of the terms are missing, which means we can just do our long division. Starting off by looking at this first term, and we're going to ask ourselves, how many times does this first x go into x squared? So by what do we have to multiply to get x squared? We would have to multiply by another x, because then x times x would give us x squared. But we also have to multiply it by the 8, so x times 8 would just be x. Then we're subtracting, and when we're subtracting, that basically changes the signs. So now this one becomes negative, and this one also becomes negative, because a negative, this was positive, is a negative, and then negative times a positive is negative. So if you remember, just change the signs to the opposite, that's fine, or do the actual distribution of the sign. Now we're ready to just add down x squared minus x squared. This first term should always cancel out. That's how you know you did it correctly. And then 14x minus 8x. That leaves me with 6x. And then I'm going to bring down my next term. So plus 43. Okay, starting over again, looking at this first x and asking ourselves, by what do we have to multiply this x to get to 6x? We have to multiply by 6 because 6 times x is 6x, and also multiplying the 6 by the 8, and we get 6 times 8, which is 48. Again, subtracting, which changes the signs, and then just adding down, so 6x minus 6x is gone, and then 43 minus 48 gives me a negative 5. There's nothing else we could bring down. That means that we're having a remainder. So putting it all back together to write it as a solution, starting off by our quotient, which is x plus 6, and then basically adding the remainder, so minus 5. We weren't able to divide this 5 by x plus 8. So that will be the solution to this long division problem. It has a few steps involved, so it takes some practice, but it's basically always the same, so if you do a couple of them, then you can't go wrong. Question number 13, this one says factor the polynomial. So there was a lot of different factoring methods, but in this particular problem, you should be realizing right off that we are dealing with the difference of perfect cubes, because this first term is a perfect cube, and the 216 is a perfect cube, and then we have a minus sign. So the sums and differences of cubes actually require you to know a formula. So I'm going to write down the one for the difference, and that would be when you have basically a cubed minus b cubed in our case, then the solution in factored form would be a minus b, a squared plus ab plus b squared. So when you're factoring the difference of two perfect cubes, basically you just have to plug into your formula. But first let's identify what is a. A in our case is basically the cube root of x cubed, which is just x. And then b would be the cube root of 216, and the cube root of 216 is 6. Because 6 times 6 times 6 is 216. And if you don't know that, for this part you actually could use the calculator by plugging into your calculator the cube root of 216, and that should give you 6. Alright, now we're ready to plug it in, and we're starting with our a, so x, minus our b, which is 6, and then a squared, so x squared, plus a times b, which is x times 6, or 6x, and then plus b squared, so 6 squared, which is 6 times 6, so 36. So there's not really any major calculation involved. You just need to memorize this formula. And you could either have one of these on your final exam. This would be the difference of cubes. And let me also write down the formula for the sums of cubes, and that would be a cubed plus b cubed. So if you have a cubed plus b cubed, then that will give you a plus b, and then a squared minus ab plus b squared. So the formulas are the same, the only thing that are different are the signs, where here the signs are alternating for the sums of cubes, and then for the difference there's only one subtraction sign, and they're the first one. Let's move on to the next question, which is subtract the rational expressions and simplify your answer to lowest terms. Okay, so these are nothing else than fractions, and when we're adding or subtracting fractions, we need the same common denominator. In this case, they are different, so we need to identify the least common denominator. To do that, this side is not in factored form, so let's first factor this side. X squared minus 4, that will be the difference of squares, and you factor that by taking the square root of the first term and the last term, which is an x and 2, x and 2, and then you just need opposite signs. And that will be a x squared minus 4 in factored form. Now, as you may see, the two denominators have something in common, and that would be the x minus 2. So for the least common denominator, we definitely need that part, but then also because this one has x plus 2, that will be also part of the least common denominator. It is basically a combination of both of them. Both of these need to go into the least common denominator. Because this side is actually the least common denominator, we can just leave it like that. But then on the other side, that one is missing the x plus 2, so we're going to multiply numerator and denominator by x plus 2, like you would if you would be dealing with just simple fractions. So on top, we're using distributive property, and we get x times x is x squared, and x times 2 is just 2x. And our denominator now is the same. I used parentheses on top because this is very important. If there is a negative sign, you have to be careful because that gets distributed to everything you get in the numerator. So I'm going to distribute the sign, which is just going to change the signs of everything inside the parentheses. So negative times x squared is negative x squared, and negative times positive 2x is negative 2x. My least common denominator is the same, and I can actually FOIL it back together, and I know what that is because I started off with it in the beginning, so I don't need to do the actual foiling. That would be x squared minus 4. And then I can continue simplifying the numerator. I think I lost an x right here. I lost my x because I wanted to simplify, and then there was nothing to simplify. So sorry for that. I lost my x, but the x is right here, and then I have two like terms, my 6x and my negative 2x. I can put them together, so that gives me negative x squared and then plus 4x and x squared minus 4 in the bottom. So these two, numerator and denominator, look really similar, but they are not. So there's nothing else I can simplify, which means this would be my final answer. But you should always check if there's anything else using factoring what you could do to further simplify this problem. But in my case, this would be your final answer. Alright, so let's do one more. And this one is simplify the complex fraction. So when dealing with complex fraction, we can actually use a pretty good method by eliminating the fractions or clearing the fractions. The key thing is that you know how to find the least common denominator. So looking at all the individual fractions, and I can make the 4 fraction as well by putting it over 1, and I'm looking at all the denominators to find the least common, so a combination of all. I got a 1, x, 3, and 6. Starting with the numbers, the least common denominator of the numbers would be 6, because 3 goes into 6 and 1 goes into 6. But then we also have an x, so that is part of the least common denominator. So now I have to multiply each individual term by the least common denominator. Multiply everything by 6x. And I can make these fractions as well if I wanted to. And then I'm just going to start up here, and I'm going to simplify my individual terms. So I cannot cross cancel nothing here, but I'm going to straight multiply. So 6x times 4 gives me 24x. But then over here I can cross cancel because I have an x in the bottom and an x on top, so they cancel each other out. And then I'm left with multiplying 2 times 6. This gives me 12. Now there shouldn't be any more denominators. All these are 1s, so they are gone. Moving on to the bottom, and here too I can cross cancel 3, because 3 goes into 3 one time and 3 goes into 6 2 times. And also over here I can cross cancel 6 because 6 goes into both of them. Now what's left, I got 2x times x, that gives me 2x squared, and then I have here, what do I have left? Just a 1 and an x. I only cancelled out the 6. So I have left 1x or just x. Okay, I may not be done because maybe there's something else I can simplify. So let's try to factor a little bit top and bottom. I'm going to factor the top by pulling out the greatest common factor. Both of these terms have in common 12. And dividing out a 12, I'm left with 24 divided by 12 is just 2x. And then 12 divided by 12 is 1. And in the denominator, I'm also going to use pulling out the greatest common factor as my preferred choice of factoring because both of them share a common factor of x. And then I'm left with 2x plus 1. So now you may see whenever I have something exactly the same in top and bottom, I can cancel that out. It needs to be separated by multiplication. If there was an addition or subtraction sign, I wouldn't be able to do it. But whenever it's multiplied, then I can cancel it out. So I'm left with 12 over x as my final answer.
Okay, so 16, solve the rational equation. All right, so continuing what you guys have been working on, we want to multiply by the least common denominator. So we have to work with x minus 2 and x plus 2. So we need to make sure and include those two factors in our least common denominator. And 1 has a denominator of 1, so it doesn't really affect what we need. So the least common denominator that we want to use is x plus 2 times x minus 2. So we're multiplying everything in this equation by x plus 2 times x minus 2. Now we're going to do it over here. X plus 2 times x minus 2. It's kind of messy. And one more, x plus 2 times x minus 2. All right, so now let's see what happens. So on the left-hand side of the equal sign, x minus 2 is canceled. So I'll have 18 times x plus 2. Then equals 1 times our least common denominator would be the least common denominator, x plus 2 times x minus 2. And then the last term, x plus 2 is canceled. And then I'm going to have plus 20 times x minus 2. So I've got a lot of distributing and multiplying to do, so let's go for it. So 18 times x is 18x. 18 times 2 is 36 equals, I'm going to FOIL these two binomials. So x times x is x squared. X times negative 2 is negative 2x. 2x times x is positive 2x, and 2 times negative 2 is negative 4, and then 20 times x is 20x, and 20 times negative 2 is negative 40. So let's make sure and combine all of our like terms on each side of this equal sign. So on the left-hand side, I don't have any like terms to combine, so I'm good over there. On the right-hand side, I have quite a few terms I can combine. So negative 2x plus 2x actually cancels to no x. So I just have my 20x, and then negative 4 minus 40 is negative 44. So on the right-hand side of the equal sign, I have x squared plus 20x minus 44. And then I'm going to bring down the left-hand side, 18x plus 36. So I want to solve this quadratic, so I need to set everything equal to 0. And so I'm going to subtract 18x and subtract 36. And I'm going to subtract it on the other side of the equal sign. Okay, so then I'm going to have 0 equals x squared plus 2x minus 80. So now I have a trinomial that I want to factor. So if I notice the last term is negative, that means I'm going to have different signs. And then if I take the sign of this middle term, that'll be my first sign in my factored form. And if it's different signs, we're going to have this be positive, then minus. And it's x squared is my leading term, so I'm going to have x and x here. So now I need two numbers that will multiply to give me 80 and subtract, because we're having negative 80, subtract to give me positive 2. So I want to think of my two numbers that multiply to give me 80. So I've got 8 and 10 equals 80. And I want to take the bigger factor, make it my first number here, and then we'll use the 8 here. Let's think about it. 10 times negative 8, negative 80. 10 plus negative 8 is 2. Or you could think of it as I need different signs, and the first factor needs to take this same sign here. You always put the larger factor first, and so 10 times 8 is 80, and then the difference between 10 and 8 is 2. So those are my factors. And then I'm solving, so I'm going to take each factor, set it equal to 0, and solve. So if I subtract 10, I have x equals -10, and then if I add 8, I have x equals 8. Okay, so number 17, solve the application of rational equations. So Martha can rake the leaves in her yard for 2 hours. Her younger brother can do the job in 3 hours. How long will it take them to do the job if they work together? So Martha can rake the leaves in her yard in 2 hours. So that means that she can rake half of the yard in 1 hour, plus her younger brother can do it in 3 hours. So that means he can do 1/3 of the yard in 1 hour. And we want to see if we add them together, they work together, how long will it take them? So 1 over, we don't know, hours. So we're going to say that's t. So we want to solve this rational equation. So we want to multiply everything by the least common denominator. So if we're looking at 2, 3, and t, we want to include each of those factors in the denominator. So 2 times 3 times t is 6t. So let's multiply everything by 6t. So I'm multiplying by 6t right here, 6t right here, and 6t right there. So 6t over 2 plus 6t over 3 equals 6t. Okay, so 6t divided by 2, that's going to cancel to just 3t, because you can divide both by 2. 6 over 3 is 2t. 6t over t. The t's cancel. All right, we're left with 6. So 3t plus 2t is 5t equals 6. Solve for t by dividing by 5. So t equals 6/5, 6 over 5. 6/5 hours. These problems you set up pretty much the same way each time. Just remember how you set up your rational expressions. And that's why I use the colors, because that's pretty much the important part of these, is to set it up that way. So 18, multiply or divide, then write the answer in scientific notation. Alrighty, so we're going to start by multiplying the numbers. So we're basically doing 7.43 times 3.51, and then we're going to multiply that by 10 to the 5th times 10 to the 6th. The neat thing about multiplication is commutative, so you can switch all that around and you'll get the same answer. So let's take care of the decimals first. So lucky you, you can use your calculator if you like. 7.43 times 3.51 is going to equal 26.0793 times, I'm multiplying these two expressions with exponents. They have the same base, so I can just add the exponents. That's 10 to the 5 plus 6, so that'll be 10 to the 11th. Now right now this is not in scientific notation. Remember that this first number needs to be between 1 and 10. And then, so 26 is obviously more than 10. So we need to move this decimal 1 to the left to make it 2.6. And we can round this. Well, I'll go ahead and write it all out for now. And now if we move it 1 to the left, that means we're going to have to add 1 to my exponent. So that's going to be times 10 to the 12th. And then we can round our decimal. Look, we round to the nearest hundredth. So we're going to round here. Look to the right, it's a 7. So we're going to say that's 2.61 times 10 to the 12th. So if you were dividing, you would do the same thing. You would divide these two numbers. Your exponents would be dividing. So then you would subtract the exponents. And then if your answer here is not between 1 and 10, which it likely wouldn't be, you would need to move the decimal to whichever direction and then make that adjustment to the exponent for the 10. Okay, So 19, rationalize denominator and simplify. So when you're trying to rationalize denominator, that means that you're trying to get rid of the square roots in denominator. So this problem is an interesting one, and you actually can rewrite the numerator as the difference of two squares. So we can think about it. So if I have the square root of x, and if I were to square that, that will give me just x. And that's what I have here is x. So I can rewrite x as the square root of x squared, because that's going to help me eventually be able to cancel out some factors in the top and the bottom. So I'm going to rewrite everything else. And just so you guys know where that came from, so this came from this situation here. So now what we have is the difference of two squares. So let's remember what that is on the side. A squared minus b squared equals a plus b times a minus b. So if I do that up here, that's the square root of x squared minus 9 squared. I can use my factor pattern and say that's the square root of x plus 9 times the square root of x minus 9. And then I'm just going to rewrite my original denominator, which was the square root of x plus 9. And so now if you look at it, I do have common factors in the top and bottom. So I have the square root of x plus 9 at the top and the square root of x plus 9 in the bottom, so I can cancel these out. So then my final answer is going to be the square root of x minus 9. Now, I know this is not the typical way that you would solve these type of rationalized denominator problems, and so we're going to look and see the other way, but for the purpose of solving the problem, I did want to show you that you could use this factor pattern for this problem because of the way it's set up. You have 81, you've got 9, you can change x to the square root of x squared to help you eventually cancel out. But this is your final answer here. Okay, I'm going to show you another way that you could rationalize this. The normal way that we've been doing the problem. So I'm going to use this to get some space. So we had x minus 81 divided by the square root of x plus 9. So the normal way that we rationalize if the denominator is like this is that we would multiply the top and bottom by the conjugate. So it would be the square root of x minus 9 on the top and the bottom. So if you look, if I FOIL the top, I'm going to have a lot of terms that I won't be able to combine. So let me focus on the bottom and see what happens. So I'm going to FOIL the bottom. So I'm just going to rewrite the top, x minus 81 times the square root of x minus 9. Let's FOIL the bottom. So the square root of x times the square root of x is just x. The square root of x times negative 9 is negative 9 square root of x. 9 times the square root of x is positive 9 square root of x. And then 9 times negative 9 is negative 81. So now on the bottom, negative 9 square root of x plus 9 square root of x cancels to 0. So in the bottom I have x minus 81. And at the top I have x minus 81 times the square root of x minus 9. Well, that's great that we didn't FOIL the top, because look what happens there. I have factors I can cancel out. So x minus 81 can cancel out with x minus 81 at the bottom, and then I have the square root of x minus 9 left over. So when I was working this problem, I'll just tell you the truth, I FOILed the top, because that's normally what we've been doing. But I realized it was very difficult to cancel anything out. But when I just FOILed the bottom, I noticed that I can then cancel out some things. So sometimes that can happen, that's okay. But we wanted to show you the other way to actually simplify this rational expression. All right? Okay, number 20. Use the rules of exponents to simplify the expression. Write the answer with positive exponents. So we're going to distribute multiplication. So we have y to the 1/3 times y to the 4/9. I'm just going to write it out. That's y to the 1/3 times y to the 4/9. And then minus, that'll be minus 9 y to the 1/3 times y to the 2/9. ninths. Okay, so when you are multiplying expressions with exponents and they have the same base, you add the exponent. So that's y to the 1/3 plus 4 ninths minus 9, and then we'll do the same thing here. Y to the 1/3 plus 2 ninths. Okay, so we need to get common denominators when we are adding or subtracting fractions. So I can change this 3 to a 9 and use 9 as my common denominator. So if I multiply the bottom by 3, I want to multiply the top by 3. And then the same thing with my second fraction addition. Multiply the bottom by 3 and then the top by 3. So that's going to give me 3/9 is my first exponent. So that's y to the 3/9 plus 4/9 minus 9 times y to the 3/9 and then plus 2/9. Okay, so you have those common denominators, you just add the numerators. So that's y to the 3 plus 4/9 minus 9 times y to the 3 plus 2 is 5/9. And so that's going to be our final answer here when we use the rules of exponents.
Let's go to question number 21, and it says solve the radical equation. So we have the square root 7a minus 4 minus 5a plus 7 equals 0. To solve this type of problem, we're going to want to apply a special type of property, and to do that, we need to bring one of these over to the other side. So let's start by adding the square root 5a plus 7 the other side, and that means on this side we are left with 7a minus 4, and that is equal to 5a plus 7. So now we can apply the property of squaring both sides, because the square and the square root cancel each other out, and then we are left with 7a minus 4, which is equal to 5a plus 7. Solving for a, so let's add 4 to both sides, and we have 7a is equal to 5a plus 11. Now subtracting 5a, that gives me 2a, which is equal to 11. So dividing by 2, we are left with a equals 11/2. If you are not able to see your answer in the answer choices, then you should go back and plug it into the original equation for a to see if you would get a true statement. But in this case, this is one of the answer choices, so a is equal to 11/2. Okay, question 22, an application. So the distance d in miles that can be seen on the surface of the ocean is given by d equals 1.5 square root of h, where h is the height in feet above the surface. So how high to the nearest foot would a platform have to be to see a distance of 17.5 miles? So we are given an equation which is d equals 1.5 and then the square root of h. And what else we are given? We are given the distance of 17.5 miles. So which letter represents the distance? That would be our d, which means we're going to plug in 17.5 for d, and that is equal to 1.5 square root of h, because we want to know how high that platform have to be. Solving for h. So first step, because this indicates multiplication, let's divide by 1.5 on both sides. So on the right side, we're left with the square root of h, and on the other side, that is going to be like a non-repeating or repeating decimal. Actually, I think it's about 11.66666. Best thing is to leave it as is, because at the end we're going to have to round. Whenever dealing with an application or word problem, you should not round within the problem. You should wait all the way until the end to then round your problem if required. So in this case, to the nearest foot. So if you take this number to eliminate the square root, we can use the property of squaring both sides again. That would eliminate the square root on the h. So now we are left with h equals the 11.66666 and so forth squared, and that will give you 136.111 something, and rounding it to the nearest foot would be 136 feet. Okay, problem number 23. Perform the indicated operation and write the result in the form a plus bi. So mainly what happened is that we don't want to have any I values in the denominator, and to eliminate them we can use the method of multiplying by the conjugate. The conjugate of the denominator would be 8 minus 2i, and we do that to top and bottom. So this now is a foiling problem, starting with 8 times 8, which gives me 64, then 8 times negative 2i, which gives me negative 16i, and then 8i times 8, which is a positive 64i, and 8i times negative 2i, that would be a negative 16i squared, because I have two of them. Okay, let's do the bottom right away too. So again, 8 times 8 is 64, and then 8 times negative 2i is negative 16i, and the 2i times 8 is a positive 16i, so that's what we wanted it, that those middle I terms will cancel each other out. And then 2i times negative 2i gives me negative 4i squared. Okay, simplifying top and bottom, right here I got two like terms, I can combine them, and I'm going to end up with 64 plus 48i, and then right here in the complex numbers section you should have learned that I squared is equivalent to negative 1. So instead of I squared, I can write times negative 1. I'm converting that I squared into negative 1. Let's move on with the bottom. We also have two like terms, but like I mentioned before, these will cancel each other out. So 64, and then again here we got another I squared, which we can substitute with a negative 1. And now what we got left. So right up here, simplifying the top, 64 plus 48i, and then negative 16 times negative 1 is now a positive 16. And in the denominator, a negative 4 times a negative 1 is a positive 4. And then continuing with like terms right here, those two, we can combine them, and now we get 64 plus 16. That would be a 80 plus 48i. And in the bottom, 64 plus 4 is 68. So we could have also wrote this 80 over 68 plus 48i over 68, and then both of these fractions could be reduced. 80 and 68 are both divisible by 4, so reducing them we will get 20 over 17, and then also 48 and 68 are divisible by 4, and we are left with 12 over 17i. Let's move on to 24, and this is solve the equation by factoring. So I really do like factoring, especially since we learned factoring, we have used it almost for everything. And this is a factoring problem with a coefficient of 1, so that should be simple. Writing your empty sets of parentheses, and then square rooting the first term, so you get an x and an x, bringing down the first sign, multiplying the two signs together to give you the second sign, so a negative times a negative is a positive, and then looking at the factors of the last number, which is 27, and when there are different signs inside these parentheses, the factors must subtract to give you the middle number, in this case 6. The factors of 27, there are not many, So it should be 9 times 3. And yes, 9 times 3 is 27, and 9 minus 3 is 6. So the larger of the two factors first, smaller one second. Now we factored, but because this is set equal to 0, we can apply the zero product rule. The zero product rule means that either one of these two factors should be equal to 0. So we set them each one individually equal to 0 to find the solution. Solving the left side, so adding 9 to both sides. That gives me x equal to 9. And then on the right side, subtracting 3 from both sides, and we get x is equal to negative 3. So our two answers should be 9 comma negative 3 or negative 3 comma 9. Both of them are correct. Usually in math, you write them in descending order, or the smallest one first. So both of these are correct. Okay, number 25. So solve the equation by completing the square. This would also be a factoring problem, but I'm pretty sure the reason why we have to complete the square is because we are not capable of just factoring it the regular way. And we will see why once we found the answers. This one is already prepared. For completing the square, I need the constant on the right side of the equation, which is right here. And then I need to know a little formula, which is b divided by 2 squared, to make this perfect square trinomial on the left side. My b, and this comes from the quadratic equation in standard form, which is ax squared plus bx equals c, and right there in front of the x term, that will be my b. So in this case 14. Plugging in 14 for my b into this formula, and I will get 14 divided by 2 is 7 squared, and then 7 squared is 49. So now this number, to create my perfect square trinomial, I have to add that to both sides. Rewriting the left, so adding 49 to the left side, and also adding 49 to the right side. Now my left side, I know this is a perfect square trinomial, so factoring it, I should get x plus 7 squared. If you don't know that, then you can just factor this the regular way, but you should get this answer. And then on the right side, negative 39 plus 49, that gives me 10. Now we can apply the square root property. So to get rid of the square, we could square root both sides, but when we do that, we get a positive and a negative answer. So over here, the square root and the square cancel each other out, and we are left with x plus 7. And then on the right side, we have positive or negative square root of 10. We cannot take the square root of 10, and 10 does not have a factor where one of them is a perfect square, so this is just fine. But we need to solve for x, so let's subtract 7 from both sides. X equals negative 7, and like I said, we get two answers, positive square root of 10, but also x could equal negative 7 with a negative square root of 10. And because of this answer, that was the reason why we weren't able to just factor this problem in the beginning, why we needed to use a different method to help us. And in this case, this method is called completing the square.
Okay, so use the quadratic formula to solve the equation. So let's recall the quadratic formula. So it's x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Okay, so let's identify our coefficients. So remember, we're getting it from ax squared plus bx plus c. So a equals negative 4, b equals negative 9, and c equals negative 8. So let's take our time and plug in everything. So we have x equals negative b, which b is negative 9, plus or minus the square root of b, which is negative 9, squared minus 4 times a, which is negative 4, times c, which is negative 8. And then all of that is divided by 2 times a, which is negative 4. So just take your time and write everything out. So let's clean this up a bit. So negative times negative 9 is positive 9 plus or minus. Okay, the square root of negative 9 squared is 81. And then negative 4 times negative 4 times negative 8 is going to give me a negative 128. And then that's going to be divided by 2 times negative 4, which is negative 8. So then that's x equals 9 plus or minus the square root of 81 minus 128 is negative 47 divided by negative 8. So we have a negative under the square root. So we want to go ahead and get rid of that, pull it out of that square root, and make it an I. So that's going to equal 9 plus or minus I times the square root of 47, all divided by negative 8. And so now if you look at your answer choices, this is actually giving you two different answers. It's giving you the one that involves the plus, so that'll be 9 plus I square root of 47 over negative 8. And then we have 9 minus I square root of 47 divided by negative 8. If there's any questions on quadratic formula, we're going to use it one more time in problem number 27. So solve the application of a quadratic function. So a ball is thrown upward with an initial velocity of 21 meters per second from a cliff that is 70 meters high. The height of the ball is given by the quadratic equation h of t equals negative 4.9 t squared plus 21 t plus 70, where h is in meters, so how high the ball is in question, and t is the time in seconds since the ball was thrown. Find the time it takes the ball to hit the ground. Round your answer to the nearest tenth of a second. So if the ball hits the ground, that means we want to find when the height is 0. So basically we want to say 0 equals, so what would be t when the height is 0? So I'm going to rewrite my quadratic. And so we want to basically solve this using the quadratic formula. So as a reference, I'll just write it here, and I probably should use t instead of x, but well, I'll just keep it like that. Negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. So let's identify the coefficients. So a equals negative 4.9, and remember we're getting it from ax squared plus bx plus c. That's our standard form. So a equals negative 4.9, b equals 21, and c equals 70. So in this problem, yeah, the 21 and the 70, that's information that was used to create your equation, but you're not having to use it other than what it's already, the way it's already in the equation. So let's use the quadratic formula. I'm going to say t equals, since we're talking about time, negative b, so that's negative times 21 plus or minus the square root 21 squared minus 4 times negative 4.9 times 70. All of that divided by 2 times negative 4.9. Okay, so now we have negative 21 plus or minus the square root of 21 squared is 441, and then negative 4 times negative 4.9 times 70 is going to be positive 1,372 divided by 2 times negative 4.9 is negative 9.8. So now t equals, I'm going to add under my square root, so 441 plus 1,372 is 1,813, all divided by negative 9.8. So I think it's best to round as little as possible. So I would strongly encourage you, using your calculator, to do the numerator as it is and then get an answer and then say divided by negative 9.8 and then round your final answer. All right, so I'm going to just rewrite the two solutions. So negative 21 plus the square root of 1813 over negative 9.8, and then negative 21 minus the square root of 1813 over negative 9.8. So we're going to get these approximate answers using the calculator. I'm going to show you what I mean. So I'm going to do, for the first one, it was negative 21 plus the square root of 1,813. You could do that all at once, or you could totally do this. You can say enter. So that's the numerator. And then I want to divide by, if you just automatically press divide by, it takes your last answer, and you want to divide that by negative 9.8. So one solution, and if we round that to the nearest tenth, will be negative 2.2. So I'm going to go back and write that down. So negative 2.2. All right, and let's do the other one. So negative 21 minus the square root of 1,813 equals, that's my other numerator, and I want to divide that by negative 9.8. That's going to give me positive 6.5. So positive 6.5, and we are approximating. Now those are two answers, so which one do I want? So we don't want the negative value because it says find the time, so there's no negative time. So we want the positive value. So that's telling us that it's going to take them 6.5 seconds to reach the ground. And so the reason why you do have that negative, because think about what a quadratic graph looks like. It's a parabola. So but in reality, this parabola, we are having it relate to throwing a ball. So it's not going to be a full U or a full parabola shape for the purpose of this situation. But that's why there is a negative 2.2 solution to the equation. But for this scenario, we only want to keep the positive value because that's what makes sense in the real world, in the reality of this scenario. So the answer is 6.5 seconds. And again, the thing is, you could do the square root of 1813, but you may end up with having your answers rounded too much. And if you look at your answer choices, they're really close together. So you could potentially get an answer that's rounded too much. So try as best as you can to round at the very, very end, which is what we did. We didn't do any rounding until we got to the very end of the problem. All right, let's look at 28. So sketch the graph of the quadratic function. Give the vertex an axis of symmetry. So let me write the quadratic function. F of x equals x minus 1 squared minus 1. All right, so this is actually in vertex form. So vertex form, to get the vertex, okay, so f of x equals a times x minus h squared plus k. So the vertex we get from h and k. But you want to change the sign of h and keep the sign of k because it's minus h. So I always say change the h, keep the k. That's my little phrase that I use when I'm teaching this. So for this problem, you can see your h here would be 1. So you change the sign, you see minus 1, but we want to take positive 1 and keep the sign of k. So it'll be 1 comma negative 1. Change the h, keep the k. So that's your vertex. Then the axis of symmetry is going to be x equals the x value of your vertex, which would be 1. So let's plot the vertex, 1, negative 1. Your axis of symmetry, see if I can draw a straight line. Oh, this is hard. That's your axis of symmetry. Now let's sketch the graph. Okay, so if you think about it like this, we'll plug in values. So let's see, let's use when x is 0. And when x is 2. Okay, so our function is x minus 1 squared minus 1. So when x is 0, we would have 0 minus 1 squared minus 1. So that's negative 1 squared, which is 1. 1 minus 1 is 0. These are my y values. And then I have 2 minus 1 squared minus 1. 2 minus 1 is 1 squared minus 1. So that equals 0 as well. So when x is 0, y is 0. That's 1 point there. And when x is 2, y is 0. That's another point here. So I can sketch my graph. And you can always get more points by choosing more x values and plug into your table to get other values. All right, let's look at 29. Find the vertex of the quadratic function using the vertex formula. So to find the vertex of a quadratic function, we need to start by finding the x-coordinate of the vertex. So to get the x-coordinate of the vertex, that's going to be x equals negative b over 2a. And so remember, the standard form is ax squared plus bx plus c. So a equals negative 5, b equals 10, and c equals 1. But we really only need a and b for this. So that's negative b, which is 10, divided by 2 times negative 5. So that's going to be negative 10 divided by negative 10, which equals 1. So when we're finding the vertex, that's a coordinate point. That's half the point. That's 1, comma, we need that y coordinate. So we're going to take this 1 and plug it into our function and determine what the y value would be. So we have negative 5 times 1x plus 10 times 1 plus 1. So following order of operations, we're going to do exponents first. So that's going to be negative 5 times 1 plus 10 times 1 is 10 plus 1. So that's negative 5 plus 10 plus 1. So negative 5 plus 10 is 5 plus 1 equals 6. So the vertex would be 1, comma, 6. Okay, last but not least, number 30. So solve the application. So the cost in millions of dollars for a company to manufacture X thousand iPhones is given by the function C of X equals 3x squared minus 24x plus 128. Find the number of iPhones that must be produced to minimize the cost. Okay, so we can use the graphing calculator to find the minimum and the maximum. So to get to my y equals, because I'm going to plug in this quadratic into a y equals row, I'm going to press y equals. And so I want to plug in 3x squared minus 24x plus 128. Okay, so I want to graph it. So I'm going to press graph, and let's see if we can see it. We may not be able to see it. So we're trying to figure out what our window should look like. So if we pay attention to the table that we have here, your x values are low, but look at how big your y values are. So let's make our y values. So let's go to our window and let's adjust our y values. So if we're talking about, we don't need the negative number. So we'll start with the y minimum of 0 and then a y maximum of, let's put 500 just to make sure we have it all in graph. Let's see what we have now. Okay, so now we can see our parabola. So we want to find the number of iPhones that must be produced to minimize the cost. And X represents the number of iPhones. So to find the minimum, we're going to go to second, calculate, okay? So we want to choose the minimum, so that's option 3. And so it's asking you to kind of set your boundary. So left bound, you see where it's flashing. I see my minimum is right here, the vertex, the bottom of my graph. So the left bound, I'll set it there, and I'll just cursor over to the right of that minimum, set it there, and now it's asking me if I want to guess, if I want the answer, and yes I do. So I'd press enter, and so it's given me that minimum point. So it's saying the x value is 4.000006 and then the y value is 80. But we want that x value. And so the answer there would be 4,000 iPhones. And the reason why we know we need the x value is if you read the question again. So let me go back to the problem. So x is 4 and y is 80. Okay, so using the graphing calculator, we got that the x value was 4 and the y value was 80 for the minimum. But pay attention to what it says. The cost in millions of dollars, so the cost is your CX or your Y, for a company to manufacture X thousand iPhones is given with this function. Find the number of iPhones. So X is the number of iPhones in thousands. So that tells us that this is the number that we want, and it's in thousands, so it's 4,000 iPhones. Okay?
Welcome to our last online study session. This is for MAT1033C, Intermediate Algebra, and this is the final exam review study session, version A. I'm still here for you today, so I am able to help to prepare for your final exam. Let's go to our first question. This is problem number 1, and it says solve the absolute value equation. So if you have an absolute value equation, and that's indicated by these two vertical bars, the first step would be to isolate the absolute value on one side of the equation. So I'm going to isolate this absolute value portion on the left side, and I'm going to move the 9 to the other side by subtracting 9. So I am not doing nothing with the absolute value yet. I'm just going to bring it down, but then my 9 is gone on the left side and I moved it to the right, and now 13 minus 9 is 4. So now where I isolated my absolute value, I can use the property to solve absolute value equations, which means I'm going to get two different answers because the absolute value is the distance on the number line. So you could go in the negative direction on the number line and on the positive direction, and you indicate that by writing two equations. One time with a positive 4 and then also with the opposite, which would be a negative 4. So let's solve these two equations now individually. Let's start over here. We subtract 3 from both sides. So we are left with 6x is equal to 1. Then dividing by 6 on both sides, and we get x equals 1 over 6. So we have our first answer, and now let's do it again. So subtracting 3 from both sides, we have 6x. And then negative 4 minus 3 is negative 7. Last step, to get x by itself, divide by 6. And that leaves me with x equal to negative 7 over 6. So for this absolute value equation, we basically get two answers. One of them is 1 over 6, and the other one is negative 7 over 6. If you should not see your answer, then you might want to go back and plug these back into the original equation to see if you get true statements, because sometimes it happens that there is an extraneous answer, so that would be a no solution. But in this case, you are able to find the solution. Let's go ahead and see what number 2 wants from us. Here we go. Solve the compound inequality and give the solution set in both set builder notation and graph form. So we have negative 5 less than 8x plus 3 and also 5x minus 10 less than 5. These are two inequalities, so let's solve them individually. Let's start with the left side. So basically we are solving for x, so I'm going to move the 3 first by subtracting 3 from both sides. And negative 5 minus 3 gives me negative 8. And then I have 8x left, and this became 0. Okay, my last step to get x by itself is dividing by 8 on both sides. So negative 8 divided by 8 is negative 1. And 8 divided by 8 is just 1. So my x is by itself. And I can also rewrite it because I like my x to be on the left side, but I need to make sure that the value of the sign still is the same. So basically the x is greater than negative 1. So both of these answers are correct, but I prefer having the x on the left side. So now solving the second part. So here again we're solving for x. Let's add 10 to both sides. And we have 5x is less than 15. Now dividing by 5, and x is less than 3. So in this case it came out nicely with x on the left side. I do not have to rewrite it. Now first of all they want me to graph it, and here's already my number line, so I need to make sure that my -1 is on there right here, and then also my 3, and then I have greater than and less than signs. So that means that I am going to use parentheses instead of brackets, and let me erase that, not that you think it's a greater than or equal to sign. So the parentheses go along with these two signs, and then the brackets go along with the greater than or equal to sign and the less than or equal to sign. So in our case we only have these signs, so we're dealing with parentheses. So at -1 it says x is greater than -1, so the numbers are greater than -1, which means the side to the right of -1 should be shaded. And on the second part it says x is less than 3, so the numbers that are less than 3 are to the left side, which means everything in the middle would be shaded. So actually the shading from the -1 would continue over here, and the shading from the 3 would continue over here. But because we have AND, which means the solution is only where the two shadings happen, so what is the solution of both of these inequalities, and that is in the middle. So writing this in set builder notation, we need our curly braces and then x such that, and now you see how x is in the middle, so it started at -1 and x is basically greater than, which means this sign, and then x is also less than 3. So this would be our solution in set builder notation, and this would be our graph. Let's move on to number 3, which is similar, but in this case it actually says OR. So the same steps as before, we first have to solve both of these inequalities separately. So let's start with the left side by solving for y. So let's subtract 5 from both sides, and we have -4y is less than 17 minus 5 gives me 12, and then dividing by -4 on both sides. And whenever with an inequality we multiply or divide by a negative number, like in this case,